Hi, my name is Matt Jacobs, and this is the Lab03 for Physics 1. So in this lab, we have two parts. Part 1 is finding the mass of a unique black hole given to you by the seed of your Georgia Tech email. Part 2 is creating a trajectory that allows the spaceship to fly near and orbit the black hole without crashing into the black hole or the planet. So with these lab, we have two concepts that we use mainly, Newton's second law, which is the momentum principle, and the gravitational force. So Newton's law is used in F net is equal to dp dt. F net is split into two components, parallel and perpendicular, and F net is equal to the sum of those components. And same thing with dp dt, where it's equal to the sum of its parallel and perpendicular components. For gravitational force, we're just using the equation F is equal to g m1 m2 over r squared times r hat, and we are rearranging it to where we can find m2. So for part 1 in the code, as you can see, we have the seed right here. We have the mass of the star, which we were supposed to change due to the given prompt, delta t, which we changed to the given prompt. And then on the right, we have like v initial, v final, which we use to calculate p initial and p final. And then that allows us to find delta t and delta p. And then we find dp dt. And then we set f net equal to dp dt. Basically, this is just using the gravitational equation F is equal to gm1 m2 over r squared. We're basically substituting out F to be dp dt, and then we're flipping sides of things to where we have m1 on itself, which is the mass of the black hole. So we have m1 or m2, m1 the mass of the black hole is equal to dp dt times r, which is right here, r squared because the black hole is located at the origin, divided by the gravitational constant times the mass of the star, which gives us the mass of the black hole. So when running the code, it gives you 439 different options for the mass of the black hole. So I averaged them all using an Excel sheet to find the mass to be 1.3408 times 10 to the 34th. And then this also gives me F net, F perpendicular, and F parallel as well right here under the code, or under the code output, I guess. And so for part 2, our code, we put our mass of our black hole in right here on the left, and then on the right, it just basically is me showing you that I used all of the data to find the force of gravity on the planet from the ship and from the black hole, and then on the ship from the planet and the black hole as well. And then using those, I was able to create this, which shows my model of the ship going to the black hole but not getting sucked in. And here's my initial velocity. I had the x velocity be -5 times 10 to the 7th, and my y velocity be 1.67 times 10 to the 6th is what I found to work best for me. So that allowed us, the ship, to not get like sucked into the black hole or collide with the planet. And so for discussion, what does this mean? In this lab, we found that dp dt is equal to f net, and so that answers the question of the what does it mean question for this lab, because it shows that f net is equal to dp dt, so therefore you're able to interchange it using its parallel and perpendicular components. And then for the what if question, if you were to try to orbit the black hole, that is possible. I just had to mess around with the numbers a little bit to find the right speed for x and y to be able to find that. But as you can see with this T max change, originally it was 60/60 times 2, but now it's 60/60 times 5. So it allows for it to orbit. Thank you very much.